2017.
Hi guys, so this talk is called Keep News Tools Safe. So just a tiny bit of background first. So my name is Arnaud. I joined a bunch of crazy people in 2011, and I work not so far from here on a project that some of you know. When I joined, I had no idea exactly what I would be working on, but something interesting happened. Is that IDA had just been released, like its couple first versions, using Qt as the toolkit. And unfortunately, the guy who did the port, Daniel Pestelli, whom some of you know, actually left the company at that time, giving a lot of meaning to the buzz factor thing, because he was the UI guy and nobody else actually really knew how to handle the UI. So that was maybe a bit of a problem there. So first of all, just to make it clear, we have two big categories of bugs in IDA. We have first the kernel bugs, which typically can affect the loaders and processor modules and everything. They're all about the disassembly itself. And then we have another class, I would say, of bugs, which is typically the UI bugs, which is everything user interface related, happy crashes and things like that. And this talk is about the actual the UI bugs, not the what we call the kernel bugs. So it's IDA's kernel, not the OS kernel, obviously. So this is about UI bugs and how we deal with those. So the UI, when I'm talking about UI, it's not about, hey, this button is misplaced or anything like that. We know they are, right? This is about basically the rendering pipeline, how the stuff that you place in your IDB is actually rendered on the screen. That's what we call the rendering pipeline. This is about that. I was not particularly inclined to go down that road, but then again, it's not as stupid as positioning buttons, so it's actually fairly interesting. And anyway, we still had bugs coming in, and somebody had to take over because, well, the situation was not exactly great. Especially, we had the blanket problem where when I fixed one bug in one place, it actually typically broke something in the other place. And of course, then you rush to the other place, you fix it, and it broke in the first place. Which you can do that forever if that's your thing. But we decided we would try to do better. So. Whatever I wanted to do, whatever I fixed, we wanted to make sure that this was fixed properly and did not happen in the future. The best way to do that, obviously, is non-regression tests. Non-regression tests for UI, however, are not exactly trivial, given that we actually wanted to have a platform-independent testing framework. We obviously want them to be automated, and we don't want to have to rechange all the tests every time the UI changes a little. So we want to be able to access the parts that we're interested in for a specific test and deal with that. And also, the results must be easily interpretable. That's AKA text files, so that we dump in text files whatever we're interested in. That's good because then it's in our servers and repositories, so we know the history of tests. We can do relevant operations on those. Just a quick parenthesis here. In my previous job, I was working on something, and literally a team of guys in Atlanta was. Where the HQ of the company I was working for was, they were literally just recording tests because a lot of UI testing is done through what they call UI recorders. So you just launch the application, you click in places, and then it does typically screenshot comparisons. Unfortunately, the product was under heavy development, which means the guys literally, and I'm not making this up, they were just re-recording all the tests every week. That's all they were doing. And I mean, we're a small team at Hexrays, and we don't want that. And in fact, I don't think anybody should ever want that. I mean, this is an indecent job, in my opinion. But anyway, so we investigated a few options for tools that would help us achieve the goal we set up to achieve. Among all of those, the three that I list here, one was less brain dead than the other out of the box. It's called Squish by a company called FragLogic. It's scriptable in Python, among other things, because it supports like 6 or 7 languages. So you get to choose whichever you want. And the very important part is that it has an easy access to the Qt widget tree, which is kind of what we wanted. So there's a lot of buzz going around in Squish. If you go to their websites, you may get nauseous at the word salad that they stuff in there. But never mind, Qt widget tree. Again, this is what we wanted, and we got it, and that's fine. So just a quick rant, these test recorder things, don't use them. They're stupid. Literally stupid. Even Squish's test recorder, because they have one, they have to. If you start clicking in places, it will actually have to put sleeps in order to make sure that the test will run again just fine. And in fact, it's not even a guarantee. It's just hopefully it's going to run again. No way that this stuff is platform independent. Of course, that is if you run the test on OS 10, obviously the widgets will be at different pixel coordinates. Duh. So my advice would be just stay away from it. It's completely dumb. Another completely and also a lot of UI testing is done by comparing screenshots, which I'll let you guess if that works well. There is this whole page on the Squish, the FrogLogic website, and they explain like, okay, this is unknown reason for screenshot differences, obvious reason for screenshot differences. In other words, screenshot comparisons don't work. Just don't do that. Because then what they start doing is fuzzy comparison of screenshots. And then, of course, there are some items that you don't want, but they pass the test because of the fuzziness. So this is exactly what you don't want to be doing, in our opinion, at least. So just a brief, very, very brief on the Squish architecture. It basically it runs Python tests. In our case, we chose Python, and it sends commands to a third-party tool that's called the Squish server, and that actually is in charge of launching the application and then dispatching the code into the application. This is not that interesting. This is typically what happens. You have the test script on the left, then you have the Squish server, and that launches IDA. And so if you wait for a special widget, for example, it's going to say, okay, wait until this widget is available, that is, it's visible and active, and then it's going to return a pointer, so to speak. And then if you call vertical scroll bar to get the scroll bar on that particular widget, then it's going to send invoke get scroll bar basically on that widget to the server. The server will do its thing and return another pointer, and so on and so forth. So basically, it's just it's an RPC mechanism, really. RPC wrapping the Qt interfaces in our particular case. So that's great. The way Squish itself is built is that when you want to build it from source, you need to provide a Qt source tree, because what it's going to do is that it's going to parse all the headers and generate IDL, therefore indefinite interface definition language, for all of the headers that it encounters, and it's just going to generate automatically a lot of stubs for you, like this vertical scroll bar method call that I showed above. It knows that that thing has a vertical scroll bar method at all because of this IDL, and therefore you have an easy access to the existing Qt widgets, which is great. But IDA has a lot of custom widgets, and we don't build Squish against this. In fact, maybe that's the road we should have taken, that is injecting our own widgets in it before building it, but we chose a different approach. And the problem is that our own widgets, so what I call the rendering pipeline, typically things such as this, like the disassembly view, these widgets are complete black boxes to Squish, which means whatever you do, yeah, what am I doing here? Right. What? Where is it gone? Where is my other? I'm sorry. 3 fingers swipe to the right. But more? Left? Brilliant. I do not see who you are, but you will definitely get a free coffee after. This is really cool. Okay, so again, whatever operations you want to be doing on our own widgets, I will not go back there because otherwise I have to do 3 finger swipes again. All Squish will be able to do, if we record that, is going to say, okay, click at this position and then drag, for example. Not going to work for us, again, because of font size differences or platform differences, a lot of possible problems, really. Now, you may say, yeah, but stick to just one font size. No, don't do that, because some tests, anyway, will need to use different font sizes precisely, because in some cases, we want to check that font sizes work fine. So, okay. What we introduced is just thanks to one thing that's called the Qt Meta Object Protocol. On our own widgets, we have just one entry point that we call the Squish facade. It's just basically in charge of returning a Qt object that can be introspected. and that Squish can do. So it cannot call the original methods of our widgets, but through the Squish facade, we can have bridges, basically, to our methods. That means now we have an entry point to calling stuff in our own widgets, even though Squish itself does not know natively about our own widgets, and that's actually pretty cool. This is a facade over a type of widget we call the custom item memo, and basically it has this. It has one property, like the render type, whether we're in the flat mode or graph view, for example. And as you can see, the slot there, what they call a slot, is something introspectable. The get render type will just return resource render type, in fact. So it's just literally just a bridge. It's usually what it does. It's just a trampoline, so to speak. And so this is I moved everything from the custom widgets, because initially I started putting those discoverable properties and slots on our widgets, but it quickly became a mess. So that's why I extracted them into a facade that I could just retrieve and work on them. So you have something like this on our widget now. We define a public Squish facade property, which expands to blah. Not so interesting, but it's basically just a bag of properties and accessors, right? Sort of a namespace, if you will. I mean, you can call it that if you want. And they just do very little. They just query. So that's just our use of Squish with our own widgets. And once you have that, you would typically call it like this. So you would wait for a specific kind of view, in this case IWA, so the disassembly view, and then you would retrieve the Squish facade and then call on the Squish facade, and that calls into our application and retrieves our own custom widget specific stuff. And then, of course, you wrap it up into more or less well-defined APIs, because we didn't exactly know where we were going first. So our APIs are a bit of a mess in terms of coherency, but it doesn't really matter. What matters is that they work. So thanks to the Qt Meta Object Protocol, this kind of thing is feasible, and this is really, really, really cool. So then we started writing tests. We wanted to have pretty small scripts, because otherwise it's dumb. And we want the results to be text files, just easy to stuff into an SCM and then do comparisons over them. This is an example test, for example. The first line is just an alias, but then I call on the view, I just say, okay, go flat mode, then jump to a certain address, and then go up. And then go to graph, and then make sure that the current EA makes sense, for example, right? Because there might have been a problem there. I don't know. This was extracted from a test. So ih.out at the end is typically what will end up into the listing file that we will actually submit in before. So that would be the test result, basically. So a few numbers. So we started actually writing stuff in April 2013, and we've been at it since then. At the time of this writing, this is a small presentation I gave some time ago, actually, there were 400 test scripts, but in all tests, the test scripts are basically themes, and in all of those tests, we have multiple, what I call phases. So if you take into consideration all of the phases of all of the test scripts, we literally test for thousands of things, which is not too bad. And yeah, some pictures, some numbers rather. This, as you may guess, is the curve of the tests as we started writing them. So as you can see in the beginning, we had a bit of a hard time setting it all up with Squish and everything. So finding our marks, and then it started at some point in 2013, by the end of 2013. And then we have a huge curve going up there. This is basically me spending a shitload of time writing tests. And then, fortunately, the curve softens a little bit, which means that, hey, there are probably less bugs now, right? And one thing that's probably worth mentioning is that around that time, around here, there was, and this is a little bit of an achievement I'm proud of, there was a massive refactoring in IDA between, okay, so the red line here is the IDA release 6.8 service pack, and the other red line is IDA 6.9, and in between there was a massive refactoring in the UI, and when I say massive, it's massive. And thanks to the test, we hardly noticed real world problems during our beta testing, and even more so after the release. So it actually works, right? It's a significant amount of work, but it definitely is worth it, in my opinion at least, and I believe I'm not the only one thinking that. So the typical average output log size, again, this must be readable by a human and the comparisons must be feasible. So we end up with logs that on average are about 200 lines. The average test size is typically 74 lines per script, which is not big. And they work well. I mean, that is, they work usually cross-platforms. We have less stability on OS X and Windows. In fact, my platform of choice being Linux, this is where I focused the most, and this is where the tests are by far the most stable and the fastest. And as you will see, I have a certain advantage by working on Linux on this. Right, so difficulties. I believe that UI testing is actually fairly hard. A lot of companies don't even bother because it's pretty hard. But IDA has a fairly large surface of actions, and if you don't test that, it's easy to not even notice that you broke something, and then the release goes out and people start complaining because, hey, I'm using that all the time, now it's broken. Yes, sorry, we didn't notice. So a lot of companies, I think, don't even bother, and if they do it in the way that they record the tests, and quite frankly, no. Yeah, so we have first we have Squish, and as I said, I introduced the notion of the Squish facade over our own custom widgets, and then on top of that, we had to slap our own scripts helpers. So this is a total amount of lines just for the helpers. That is, all the tests will typically use those helpers. I have about 11,000 lines right there, just to have a cross-platform kind of user-friendly interface for writing tests. Yeah, so the tests are pretty damn stable on Linux, and as I said, a little less on the Windows and OS X, but they do run. And a colleague of mine, Troy, added recently a bunch of tests for iOS debugging, and obviously those must be run from a Mac platform because Apple. So Linux as the reference platform has one very, very great advantage is XVFB, suggested by my colleague Ramiro here. XVFB, I don't know if you know what that is, but it's basically an X server, therefore the Linux visual interface, except it's in memory and it fakes the inputs and outputs, which is cool because then we can actually run the tests. The Squish tests actually require input and output. That is, they need a mouse. They will literally go and click on buttons and things. So that's pretty annoying when you're working and you run a test and you have I think everything happening on your screen. This is a little bit upsetting. So XVFB is super because not only does it let you run tests in XVFB and therefore does not interfere with your work, that's the first bonus, but you can parallelize it. So now we run the tests literally by buckets of 16, and there you go. So at the time we have, right now we have maybe a little less than 500 tests, and running them all takes about half an hour, I would say, which is not that big a deal. And we get, since obviously it's in continuous integration now, driven by a test driver that I will mention later, we get results every now and then, like multiple times a day, obviously, saying that, hey, this just broke and it's a great help. We couldn't find any way to have an equivalent on Windows and on OS X. We had a kind of a clutch on OS X, but it didn't really work. But running on XVFB and parallelizing them just made our lives so much better. So yeah, this T2 thing is actually the test driver, which helps run a lot of things, including the UI tests, but not only. And with this test driver, I have added a few things such as the flag look for trouble, which means that it will run the specified tests endlessly until it finds a failure or a crash or any kind of trouble, really. -J is typically the same as with make, so multiple processes. Video capture, that's cool, because when you run in XVFB and something goes wrong, well, you don't have visual feedback. But now with video capture, using FFmpeg for the capture and mPlayer typically for the playback, I can actually see frame by frame what's going on, and that is super helpful. And then there is also wait for debugger, which is very, very cool, because whenever something goes, it gives me the ability, together with XVFB, gives me the ability to launch endlessly the test, and as soon as IDA starts, it plugs a GDB into it, and so with specific commands, so that if the tests crash, well, it stays right there, but if the test succeeds and IDA exits, GDB exits as well. So it's automated, again, in UI testing, because it's events-based and everything, crashes are very, very, very hard to reproduce. But thanks to this, I mean, I could, for example, open an event in new tab. This is something that happened. So I ran this particular test called tracing MISC, looking for trouble any and dash J1 meaning inxVFB. This is in a VM, but still. And then dash W, which is the short for wait for debugger. And so the test, as you can see, ran quite a few times here. And then at some point, eventually, I received a zigzag, and I have a backtrace, a proper backtrace, and I can actually investigate all that stuff at ease. So that's like massively helpful. Yeah, so the future directions, Igor, my colleague, suggested maybe doing some kind of fuzzing, but it needs to be heavily directed because otherwise it's just a waste of time. But I believe that once we are a little bit more comfortable with all that stuff, yeah, it's definitely possible. So yeah, whenever you report a bug, depending on the nature of bugs, as I said in the beginning, you will fall into two big buckets. Either it's what we call an IDA kernel bug. It's typically processor module, loaders and all that stuff, auto-analysis. Or it's a UI bug, in which case one of us will actually add a UI test for it first before fixing it, obviously. And yeah, you'd be surprised by the amount of things that we can test. There are some limitations to UI testing, but usually it's incredible the amount of things that we can test already. And we have we obviously don't have a 100% coverage, but it gets better every day, literally. And this is very, very helpful. And we have so much more confidence in what we are doing. So yeah, thank you very much for listening. This is all I have. If there is any kind of question, I'd be happy to answer.
Thank you for the talk. Do you have any APIs or examples so plugin developers could use tests and make tests?
No, we haven't published those. As I said briefly before, it evolved a little bit organically. It's a bit of a mess. They are not pretty. They are not. At the moment, we don't really have plans to publish them. But maybe, I mean, it's among other things because we don't know if people would be interested. So thank you for suggesting it. I don't know if the pressure becomes unbearable, we will, I guess, release them at some point. But there is no plan at the moment. And as I said, it relies on it relies on a boatload of scripts that are in a state that, I mean, I wouldn't show my mother. So yeah.
Okay. Thanks.
Yeah, thank you guys.